Alright, so we're going to look at these, well, first question here, and then we'll talk about the second one. So on the first question, we've got a bag that holds 6 marbles, 4 are red, 2 are blue. And we can do this big cumbersome table. Or big cumbersome, what do we call this? Tree diagram. I should also have my stems leading back in, but I'm not very good at drawing, so I don't like doing that. Okay? Because I am doing, for the first one, width replacement, how many reds should I see in every one of these branches? 4, and how many blues should I see?
2.
Rather than writing that though, I'm just going to put a line through, make it a dashed line for my reds, just so we can see that. Cool. So how many of these values contain 2 reds? 4 in each. Oh, sorry. What do you mean by 4?
Sorry. Just can't get 2 reds if it's blue first.
Yep, so these I already know these are gone. They're no good to me, correct?
Yeah.
The second lot, so for these 4, how many options each?
2. 4 each.
There's 4 dashed lines for each one of those, correct? So the probability of these is going to be 4 out of 6, 4 out of 6, 4 out of 6, 4 out of 6, and then these are 0 out of 6, correct? So what is the probability of all of those things added up? 16 over, because I have 16 correct successes out of 36 total options, correct? Did I have to count up every one of these? I could have, but I wouldn't want to do that. What's a quicker way? Yeah, I know that for every one of these I have 6 options, correct? So it'll be 6 times 1, 2, 3, 4, 5, 6. 6 times 6. So I count up my successes out of the number of outcomes, correct? For question B, I can use the same diagram. I just have to remove one branch from each. Which branch should I remove from the first tree? Which one should I remove?
One of the reds.
One of the reds. So I'm just going to remove the top one. Am I allowed to do that? And what about this one? Yep, get a top one. What about this one? What about this one? This one? This one? So the probability of getting 2 reds here. How many options are successful there? 3? So how many lots of 3 have I got? 4 lots of 3, which is 12. So I've got 12 successes out of?
30.
Is it 36? Well, I've got 5 by 1, 2, 3, 4, 5, 6, 30. Now are these fractions done? Are both these fractions done? What should I do with them? Simplify them. So what does that become? 4 over 9. And this one becomes? 2 over 5. So which one of these is more likely? With or without replacement? With replacement. With replacement. Well, if I represented 2 over 5 as a fraction, if I doubled that, what would it become? 4 over 10, correct? 4 over 9 or 4 over 10, which is a bigger number? 4 divided by 10 or 4 divided by 9? If you had 4 cakes and 9 friends versus 4 cakes and 10 friends, where would you get more cake? 4 divided by 9. Cool? Sweet. What's that as a percentage? 40%. Calculate that one as a percentage for me. Thank you. 44.4? Very good, 44.4%. What I want you to do now is tell me everything. I want you to write down. I'm going to give you 1 minute to write down everything you can see about this Venn diagram. I'm short of a good marker, so sorry about that, but that's where we are. So you'll see there's a purple box on the outside. I want you to give me everything you know about that Venn diagram, or that scenario.